topic I'll be talking about is non-silicate minerals. We're going to be talking about what does it mean when a mineral is non-silicate, if there are any properties that they might possess, and different types of non-silicate minerals that are present on Earth. So for me, this wasn't really a topic that I knew like right off the bat. I kind of had to do further research because I only really knew what a mineral was. For me, I knew it was naturally occurring and organic, solid, have definite chemical composition, and crystalline, but there are thousands of minerals on Earth. We're going to start off by talking about what makes a mineral non-silicate and what non-silicate even means. So non-silicate minerals are those that do not have silicon units that silicates have. So basically, if a mineral is non-silicate, that means it is lacking silicon. Although they make up a small proportion of Earth's crust, they are still very important in industrial applications and economic value. Non-silicates are known to have a simple structure considering that they are missing the silicate tetrahedral. So without silicon, they can't have the tetrahedral, which means that it's not making their structure more complicated. There are actually 6 different types of classes of non-silicate minerals, which include the oxides, sulfides, sulfates, halides, phosphates, and carbonates. And we group these classes based off what underlying ion is found in common between other minerals and the groups. Although there is a small proportion of Earth's crust that is non-silicate, we still need to have 6 groups of them just to make it a little bit easier on us. So the oxides contain types of cations bonded to oxygen, sulfides contain various types of cations bonded to sulfur, and carbonates consist of various cations bonded to carbonate. Sulfates consist of cations bonded to sulfate, halides consist of cations bonded to chlorine or fluorine, and phosphates consist of cations bonded to a phosphate group. And throughout this presentation, we're going to explore a few of those classes and other classes. So the first class that we're going to explore is the carbonate minerals. Carbonates are minerals in which common cations such as calcium and magnesium are bonded to a combination of carbon and oxygen to form minerals such as calcite and dolomite. They're known to be the most common non-silicate, which is why we're kind of exploring this one first because you find it a little more than the others. Each carbonate is known to have similar chemistry and structure, and also they are known to have similar properties, which makes them difficult to tell apart. Properties that minerals of the carbonate class could have include that they are transparent, they can be lightly colored with a white streak, they have average to above average specific gravity, are soft with good to perfect cleavage, and are soluble in acidic solutions. So here are the 2 common examples of carbonate minerals. On the left we have limestone, and on the right we have marble. These are 2 minerals that most people know of. You can kind of see them on a daily basis, or you have seen them, or you even see things that you didn't even know that are made out of limestone and marble. And you can also kind of tell that they are carbonate because on the last slide when I talked about the properties, limestone kind of has that lightly colored rock with the white streak, and then marble is basically transparent. So limestone is actually a sedimentary rock that consists of calcium carbonate. It can come in different types due to the fact that it is formed through a variety of processes. It is mostly used for construction material. You can see it used in buildings. It is also an essential component of concrete. You can use it as base of roads. It's pretty durable, and it's pretty much used everywhere whenever you go. So marble is actually a metamorphic rock that is formed when limestone goes through metamorphism. So it's kind of cool that one carbonate mineral is formed through another one. And it is also used as construction material. It is used in monuments, buildings, even like countertops, and marble has kind of become a little more popular as a pattern. So I think it is very common that marble is used in daily things and as projects. And another type of non-silicate mineral that we want to explore are the evaporate minerals. Now these aren't necessarily a class of non-silicate minerals, but they are still lacking silicon, so that means that they are still a non-silicate. And they are best defined as non-silicate rock-forming minerals that are produced by the evaporation of salt water, but they are also a product of the evaporation of ancient seas. This type of mineral is best exposed in deserts. However, it is also important below the surfaces, where they can create important natural resources or where they can host important deposits for oil or natural gas. The properties that evaporites have are that they are medium to fine coarse-grained, can have a white streak, and also have perfect cleavage. They are very durable and can be used for interior uses or exterior uses. So here are two of the most common examples of evaporite minerals. On the left we have halite, and on the right we have gypsum. So halite is the mineral name for salt, yes, table salt. Its chemical name is actually sodium chloride. So salt has many uses, obviously. It can be used for highway de-icing, sidewalk de-icing when we have snow in the berg. Salt is also an essential nutrient for humans and most animals. You don't want to have fries without salt, so it is definitely a favorite seasoning for food. Gypsum is also another example of an evaporite mineral. It is formed when calcium is bonded to a combination of sulfur and oxygen to form a calcium sulfate. It is used to make plaster, plasterboard, and other building materials. So again, another durable mineral that you see on a daily basis, yet you probably have no idea it is formed from gypsum. Another type and class of the non-silicate minerals includes sulfide minerals. So the minerals that make up the sulfide class are composed of metal cations combined with sulfur. Most of the minerals in this class are opaque with distinctive colors and colored streaks. Most of these minerals are formed in igneous environments and are also metallic, have low hardness, and tend to have high densities. Some sulfide minerals are economically important as metal ores. Two examples of sulfide minerals include copper, which is on the left, and lead, which is on the right. These are two minerals that you should be familiar with since they are kind of used daily. So copper is found in the oxidized zones of copper deposits. It was used by ancient people as a metal since its properties allowed it to be easily worked with without the processing step. Today, copper is used to conduct electricity. It is used in cooking utensils, heat sinks, and heat exchangers. And then on the other hand, lead is primarily produced by the mineral galena. The number one use of lead today is in the batteries that are used to start cars. The typical battery contains about 20 pounds of lead, and it is switched out every 4 to 5 years. So that's a lot of lead considering how many cars are on this planet. So lastly, we're going to talk about the other non-silicate minerals. They are still considered non-silicate just because they lack oxygen. They just aren't put into their own group or class because they aren't common enough to be considered rock forming, so we're just going to call them the other. And a part of this other group includes ore minerals, and ore minerals tend to be concentrated in small, localized rock masses. And the more concentrated the ore mineral is, the more valuable the mineral deposit will be. So these ore minerals have relatively simple compounds in which a metal ion is either bonded to oxygen to form an oxide or sulfur to form a sulfide. They contain economically important metals and native metals such as uncombined metals, gold, and silver. So on our left we have gold and on our right we have silver. These are two commonly known minerals with daily uses, like you are probably wearing gold or silver if you're a girl, or even if you're a man, you can still be wearing gold or silver. So gold is one of the most popular and well-known minerals, known for its values and special properties, and it is commonly used in trade jewelry. And then on the other hand, silver is the most common precious metal due to its rarity and high economic value, and it is commonly used in jewelry and photography. So these are two common minerals that you don't necessarily see on a daily basis, but you can see them being used, like their colors, their parts of jewelry, like even though they're fake, you can still be like, oh, I'm wearing a silver ring. So they definitely have come a long way considering they're an other non-silicate material. And that concludes my presentation. I hope you enjoyed. I also hope that you learned a little bit about what it means to be non-silicate and what a non-silicate mineral is. I definitely learned a lot during my research of this presentation. I learned more about the minerals that I thought I knew, and I hope that you did the same. Thank you for watching.